All right, folks, it's Bass Action back in action here. In this video, we are going to learn how to solve triangles that are not right triangles. We're going to have two different formulas and methods that we're going to look at, and we're just going to look at the first one here today, and it's called law of sines, okay? So what we're going to first do is we're going to look at this problem here to help us understand why this is a necessary problem for us and formula that we want to learn. So in this first problem, we've got two people and they're going to be facing each other. It's important to note that they are facing each other. Otherwise, this problem can be done in a variety of ways. So we're going to have two people who are facing each other and they're 1,000 feet apart. So we're going to first represent that. So we're going to have one person on this end. We'll have another person over here and they're going to be 1,000 feet apart. Now, what's going to happen is we've got, let's say Wendy is on the east side. So we're going to have Wendy is standing over here and she's going to be facing west. And she's going to have her angle of elevation up to an airplane of 35 degrees. Then we're going to have Erin, who's going to be over here on the other side. So Erin's going to be over here and her angle of elevation up to the airplane is going to be 82 degrees. Now, what we want to ultimately find on this problem is the actual height of the airplane. Okay, so I'm going to go ahead and put a P up there for the airplane. We want to know how high the airplane is off the ground. Well, we can't just draw in the height and then assume that these two pieces here are going to be 500 and 500, because if we look at this triangle, these two angles are different, which means our triangle is not isosceles. So we can't just divide the 1,000 and then the whole original triangle is not a right triangle. We can't have an 82 degrees and a 35. Our remaining angle won't be 90. So we're going to be kind of stuck in how to find either of these other sides in the triangle. This is why we need a new method, because our SOHCAHTOA methods aren't going to work and our Pythagorean theorem methods aren't going to work. So that brings us to our new formula here called the law of sines. And the way the law of sines is going to work is like this. So I'm going to draw a little triangle here. It doesn't matter what the triangle looks like, it just should look like a triangle. So I'm going to have this triangle ABC. And what we want to understand is that mathematicians will tell us that if we have this angle A, the side across from angle A can be denoted with a lowercase a. Then if I have angle B, the side across from angle B will be denoted with a lowercase b. And if I have angle C, the side across from angle C will be denoted with a lowercase c. Now I do want to point out right away that sometimes students are concerned that, hey, the lowercase c and the uppercase c look the same. But just know on any problem, if it's an angle, it will be marked with a degree symbol. So you won't have to be worried about how do I know whether it's an angle or a side. Now, law of sines is going to tell us that inside a single triangle, not between separate triangles, but inside a single triangle, the ratio, remember that's a fraction, the ratio of the side divided by the sine of its angle, so A divided by the sine of A, is going to remain consistent throughout the triangle. So A over the sine of A is the same as B over the sine of B and C over the sine of C. So I always remember this as side divided by the sine of an angle. Okay, now that's going to remain consistent. You may also, if you work with any other materials or another teacher, they might write this ratio the other direction, and that's also fine. It just has to be consistent, as we learned in Chapter 7. So let's look at an example here. I've got this triangle here, and I'm going to first sketch the triangle. Okay. So I'm going to sketch my triangle and I'm going to say A and B and C, and it's going to tell me that side B is 25, so my 25 is going to go right here. And my C, notice I've got that 100, I'm going to put 100 degrees right here. So we're going to label that as 100. Notice that my picture isn't to scale and that doesn't matter. And then side C, the side across from angle C, is going to be 42. Okay. Now, the way that we know that we need to use our law of sines is we're going to look at this triangle and we're going to say, well, it's not a right triangle, obviously, because we have an angle more than 90. And we couldn't do then Pythagorean theorem or SOHCAHTOA because those also both require right triangles. But law of sines will work because we're going to have what I like to call a link. I know the measure, I'm going to mark this here as a link. I know the measure of a side and the measure of an angle across from it. And whenever you have that situation, you can find something in the triangle. So I've got a side and I have an angle across from it and I have another side, which means we can actually find the measure of angle B. So that's going to answer our first question right here. What angle can we find? Angle B, because it's across from the 25. So when we set up our proportion here, what we're going to say is our side of 42 divided by the sine of 100, and that's going to equal 25, the side B, divided by the sine of angle B. Now remember, if we're looking for an angle, we're going to eventually need to use that second or shift button. So I'm going to cross multiply this problem, and that's going to give me 42 times the sine of B is going to equal 25 times the sine of 100. If I divide both sides by 42, these will cancel, and now I can actually find the measure of angle B. So what we're going to do is we're going to type all of this into our calculator. And when we type that into our calculator, you're going to get some decimal that will be less than 1, okay? And then you're going to use your second or shift button and make sure that you are trying this at home. You're going to use that second or shift button, and you should be able to get that the measure of angle B is 36 degrees. Okay, make sure you are trying this so that you know how to use your calculator. That's going to allow us to put this angle of 36 degrees back into our picture. You want to go back and add the information as you go along. So we're going to fill in our 36 degrees there. We now have two angles in the triangle, so of course we can find the measure of angle A. And the measure of angle A is simply our 180 minus our 100 minus our 36. And it's okay if you don't write that down, generally speaking. That's going to allow us to fill in a 44 degrees right here. This original link that we used way back here, this 42 over the sine 100, we're going to use that one more time. We're going to say 42 divided by the sine of 100, and that's now going to equal our side A, the last side that we haven't found, divided by the sine of the angle that we just found, okay? And again, we're going to go ahead and we're going to cross multiply this. Many of you are going to get to where you won't need to write down this cross multiplication, and that's okay. I'm going to draw a little line here and divide this up for us so you don't get confused. We're going to say A times the sine of 100 is going to equal 42 times the sine of 44. Again, I'm going to divide by sine of 100. The sine 100s will cancel on our left, and if you type this into your calculator, you will get your answer for side A, and we're going to round this to tenths. You're going to get your answer for side A of 29.6. Now, if we go back and we put that in our picture, 29.6, you should be able to make sure that this whole triangle makes sense. The largest measure should be across from the largest angle, and the smallest side should be across from our smallest angle. All of that should make sense when you are done. Okay, now I'm going to do one more example. We're going to look at a little application problem here. So on this application problem, we are going to have a pilot who is flying due east. So that's going to just simply mean nice and horizontal, okay? So I'm going to put a G here for Greg, and I'm going to give myself just a little arrow to indicate that Greg is heading to the east. Now, our pilot is going to avoid this severe thunderstorm. So I'm going to draw on a cloud here that says, we can't go through that thunderstorm. You can even draw in some lightning. We don't want to do that. So our pilot says, whoa, I don't want to go through that storm. So the pilot is going to make a turn, and they're going to turn 25 degrees to the north. So our pilot's going to say, hey, I'm going to fly way up here, and we're going to fill in this 25 degrees. So the pilot's going to turn 25 degrees to the north, and that pilot's going to go for 92 miles. So I'm going to avoid that storm. At some point, the pilot is going to make a turn, and this is an important language, is going to turn through an angle of 105 degrees because the pilot eventually wants to make it all the way back to the original destination. I'll put a D here for destination. So eventually our pilot wants to be able to turn and come back down to the destination. Now this through an angle of 105, what we're going to do is we're going to extend this side, and that 105 needs to go outside because what happens is the nose of the plane is out here and it's going to sweep through to point to the new destination. Now, that's going to allow us to do is it's going to allow us to fill in this missing angle right here because, of course, these two should be supplementary. So we can fill in that angle right there of 75 degrees. Well, now we're back to the idea that we know our angles. So we've got a 75 here and a 25 here. So, of course, we could fill in the last angle in the triangle by just saying 180 minus that 75 that we just filled in, minus the 25 is going to get us to 100 degrees down here in this corner. Now, looking at your triangle, it is not a right triangle, which means you can't do Pythagorean theorem, you can't do SOHCAHTOA. But what we do have is that link that I talked about earlier. This is going to be what I like to call a link. It's the measure of a side and the measure of an angle. Whenever you have that link, you will be able to use your law of sines. So question A here asks us to find how far the pilot will fly after making the second turn. That means we want to find that measure right there. So we're going to use our link, 92 over the sine of 100, and that's going to equal, we want to know side A. That's going to divide by the sine of its angle of 25. And again, we would cross multiply this. When you type it in your calculator, it's going to look like this. You're going to have 92 divided by the sine of 20, or times the sine of 25, divided by the sine of 100. That's what you're going to type in your calculator, and you should get a value for A of 39.5 miles. I'm going to put this back in my picture, 39.5. Now the last thing that we want to know is how far off course did the storm cause him to travel? So now what that means is we want to know what was his actual travel distance, okay? So well, his actual travel distance was this 92 plus the 39.5 that we already found. So 92 plus 39.5. But we need to subtract from that, what did he originally only plan to do? Well, his original planned destination was just to be able to go straight across. So if we find that measure in the triangle, I'm going to call this B. If we can find this, then we'll know what the pilot originally wanted to do. Well, our B is simply then going to be, let me get that little setup for us. It's going to be our same link of 92 divided by the sine of 100. And that's going to equal that side B, that planned distance, divided by the sine of 75. So again, you're going to go through the same algebra that you did back here, and you should be able to get a B value, a planned distance of 90.2 miles, which means our final answer, when we type that into our calculator, are 92 plus the amount they went off course minus the amount that he actually wanted to go, should give us, he went 41.3 miles out of his way to avoid that storm. Okay, so that is going to be our law of sines, and all of the problems that are going to work very much the same way. The key thing is that you are always looking for a link whenever you do not have a right triangle.